Alright guys, got a quick video I'm going to do. I don't know how quick it'll be, but I'm going to try. Got a check engine light on the Silverado. It's a P00 and a P0054, I believe. You'll see later on. O2 heater sensor code. What I'll do is I'll just kind of go through quick what I'm doing with the scan tool a little bit, what I'm going to do to check the sensor itself, how I diagnosed it, which is pretty quick and simple. Change it, and we will be using just a fluke multimeter here, and just this is a launch scan tool is what I'm going to be using there. Let me know how you like this video. You're going to ask yourselves a couple different questions. One of them being, don't you have a lift? Why are you working on this thing in your carport, and then you're on a creeper in the dark screwing around with this? Okay, here's what happens. All right, we're doing several different things at once here. You know how it goes. We're doing some body work and got parts laying around, and a couple different little metal projects that we come across, and we got this going on in the other bay, as you guys may see on some other videos. So that's the way it works. When you need your lift to work on your stuff, it's usually taken up with a bunch of crap. So without further ado, we'll continue on. Okay, I went ahead and scanned the codes and everything for this. We have P0030 heater control circuit bank 1. And we got a 53 heater resistance bank 1. These two are pretty much dealing with the same thing, obviously. And then 449, that's an evac code. We won't worry about that little guy because old Dad's going to tune that out with HP tuners here in a little bit. So I ain't worried about that. But these two circuits here, or these two codes here, we're going to go ahead and deal with. So so here's the deal with these two codes. Deals with the heater circuit of the O2 sensor. Now, that has nothing to do with how the O2 sensor is reading your oxygen content in your exhaust stream or fuel trims or anything. The only way it does affect that is the sensor is not able to heat up very quick or quick enough to accurately start measuring your fuel trims and different things as quick as it's able to. Back in the day, they didn't have heated O2 sensors. It took the O2 sensors a while to heat up temperature for them to start reading your oxygen content in the exhaust, which is how it determines your fuel trim and how rich or lean your engine's running. And of course, it uses that information to basically make the engine run as fuel efficient as possible. So when your oxygen sensor is not heated or your heater circuit is not working, the O2 sensor is not reading accurately. It's going to be real slow. If you watch it on the data stream, it will be really, really slow. If you have two of them, you can put them side by side in your data stream on your scan tool, and the other one will be switching from rich to lean, and you want it to switch at least once every 3 to 5 seconds from rich to lean. The other one will not. It'll baseline. So that's an easy way to also confirm that your O2 sensor heater is not working. Now, we're not you don't really have to go into the data stream to see that, to diagnose this. What we're going to do is we're going to go straight to the simple things. It's a 12-volt circuit. It's a simple circuit. It's the same circuit as a cigarette lighter, essentially, or like a heated seat or anything like that. It's got a fuse. It is switched on and off by the PCM, by the computer. So the things that can be wrong is obviously the O2 sensor itself. The fuse could be blown, which could be caused by a short, or the sensor itself bad. A short in the sensor itself causing, to blow a fuse. So then you could put a fuse in it and it'll pop. More than likely going to be the oxygen sensor on that, or something like that. You can have a bad wire in the wiring harness, which is, in this case with the codes that we have, is high resistance. The computer's seeing high resistance, which means an open. There's not a circuit connection. So either you got an open circuit in the O2 sensor itself, a bad sensor, or you have a bad wire somewhere that's corroded and broken or something like that, or in a connector, bad connector, all the way up through to the PCM. The computer could be bad. That's probably the last thing I'd probably think would be the bad computer. Have I seen it? Yes, I have. Not that many times on this particular issue. Very rare. I've had a bad fuse, then you put it in there, it popped because it's shorted, usually in the oxygen sensor itself. Generally, 90% of the time or something, in most of this stuff, it's going to be the component that is physically working the hardest, or taking on the most vibration or heat, which in this case is going to be the oxygen sensor itself. So I'm going to go through a few things. I don't know if I'll do a video on checking the fuse. Everyone can mostly check the fuse themselves, see if that's open or not, and checking wires and different things. What I will do, and what a dealership mechanic's going to do, which I was a dealership mechanic, so this is whatever. I'm going to check the fuse first. I'm going to go down there and go to the 2 pins on the oxygen sensor that are for the heater. You're going to have one in and one out, and I'm going to check resistance with the meter. So stay tuned. All right, got both sensors on the data stream here. Not warmed up yet. The top is sensor 2 and the bottom is sensor 1. I'll give it a little punch there. As we can see, even though they're not warmed up yet or anything, we're still kind of cold. Bank 2 was responsive to what I wanted to do. Okay, now look at this. All of a sudden bank 2 is responding. It's warmed up by the heater circuit of the O2 sensor, and right here in the middle, about, as you see, 0.6, about 0.5 is the median. So as you can see, it's switching very well. It's going up and down, lean, rich, rich down here, lean up here. See how it's kind of leveling itself off. Now notice what's happening. The blue line, which is your bank 1, the one we have a heater issue with, is not doing anything. Did not respond to that. Didn't respond to it. Bank 1, not doing too much. But bank 2 is doing pretty decent. And it's not even operating temperature yet, but that sensor's warmed up, or it's warming up. It's very responsive. Again, that's bank 2 is very responsive. Bank 1 not doing a lot. Now, anytime you're looking at a O2 sensor anyway, like it's not working right, about every 5 seconds it needs to at least switch one time from rich to lean. That's above 0.5 and below 0.5. You want to see that switch at least once every like 3 to 5 seconds or so. I like to see about 3 to see it do something. If not, you know, heater or not, if not, it's not really going to set a code for that. Sometimes it'll just kind of run crappy, maybe bad fuel economy. It needs a sensor because it's not switching. It's lazy. That's the term. Lazy O2 sensor. That bank 2's a rock star. Bank 1's not doing nothing. We're not quite up to operating temperature yet on the motor. Yeah. So I'm expecting bank 1 to start kind of following bank 2 here when it gets up to operating temperature. We have a little bit of response here now out of bank 1. Bank 2 doing its thing, leveling everything out because it's nice, warm and ready because its heater's working. Bank 1 heater ain't working. It's still cold. It takes a while for these to heat up or to warm up and get efficient on reading. So we got a bam. Number 2's doing great. Number 1 ain't doing too much at all. Now, especially if you're flat rate, as I used to be, but with flat rate, do we want to sit here and read these forever for this thing to warm up? We already got a code. We know that bank 1's not really going to be reading or doing much until it warms up. Bank 2's working good. Bank 1's not working. We could sit here and waste time with this but we already know this is probably going to warm up and start reading right along with bank 2, because you know. Now let's say it does or doesn't matter. No, because we're probably going to be changing the O2 sensor anyway for the heater, probably, right? So we'll go ahead and check the fuse. We're going to go straight to the connector on the O2 sensor itself before it's 1,000 degrees down there. It probably already is. And check for resistance. And it's probably going to be open lead, so OL on your data, or on your meter. So we'll get at her. All right, got the old one out here, got the new one. You always want to make sure they look the same, obviously. Got the meter set up here. I'm going to check the old one here and show you what I'm talking about here. Pins C and D for the heater, which is the circuit in question today, should be open. Yep. So we're open lead on the meter here. Okay, C and D. Now this should be like between 5 and 16 volts. And C and D on the new one, just for fun. Obviously it should be good, or we got a problem. Okay, what are we at? 8, 7.5 or so, between 7 and 8. So we're good. We're gonna stab it in there. All right, got her changed. Got the data stream back up here. See if you can actually see it here. Both of them are doing what? They're changing actually pretty quick. Pretty nice. Very, very nice. Very nice. And just to show you, we're not at operating temperature. We're about the same as we were when the Bank 1 sensor 1 was not doing anything. And now it heats up real quick, bam, and it's good to go. Good to go. Now mind you, this isn't the best scan tool in the world, but it's good enough for the girls I go out with. I hope the video is informative, entertaining, whatnot. So like and subscribe if you like what you see. So I'll continue on with this garbage later.